Assalamualaikum warahmatullahi wabarakatuh. My name is Nohar Izzat bin Nur Azizi. Nombor metrik AA 220041. We are from group 7 from section 1 and 2. We will present about force, mass and acceleration. Here is our content. First we have introduction, then theory, then example question, then discussion and conclusion. Here is group member. First we have Sufi Shukri, then we have myself, Nohar Izzat, and Zaim, then Amira and Anissa. Okay, first introduction. Force, mass and acceleration are fundamental concepts in physics that play a crucial role in understanding the behavior of objects in motion. Force, symbolized as F, represents any influence that can cause an object to change its motion. It can result from various sources such as gravity, electromagnetism, or applied force. Mass Mass denoted as m refer to the quantity of matter in object and determine its inertia. In other words, it measures an object resistance to change in motion. Then acceleration, represented as a, signifies the rate at which an object velocity changes over time. According to Newton's second law of motion, the acceleration of object is directly proportional to the net force acting upon the it and inversely proportional to its mass. This fundamental relationship allows us to understand how force and masses influence the acceleration of objects in the physical world. Okay then, for the example, question 1. If the car in example 1 had mass of 1.5 tons, what force was required to accelerate in a straight line at 1.6 meter per second? What is the force? For the solution, we can see the free body diagram. The mass is 1.5 tons, equal to 1,500 kg. Acceleration A equal to 1.6 meter per second square. From the Newton's second law, F equal to ma. F equal to 1,500 multiplied to 1.6 equal to 2,400 Newton.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shafiki Rashad. Today I will talk about the second question. Lift accelerate with a man inside. A person of a mass 65 kg stands on a force scale inside a lift. What is the reading on the scale in Newton when A. Lift is stationary, lift accelerate upward at 2 meter, C. Lift is moving upward at 4.5 meter, D. Lift decelerate to the top floor at -2 meter. E. Lift accelerate downward at 2 meter. F. Lift is moving downward at 4.5 meter. G. Lift decelerate to the bottom floor at -2 meter. So the solution is the first thing you have to do the FBD. What is the FBD? FBD is free body diagram. So first, we know that the weight force is W equal to mg. Then, when we find the weight force, W equal to mg by adding or removing the acceleration force, that is F equal to ma. So, the mass is given is 65 kg, and G we all know that this is 9.81, and just put in the formula and you get 637.65 Newton. This is upward. What is the tail doing to the body? Minus to push up. Uh,
Okay.
so the next question is B. F equal to ma. So the mass that is given is 65 kg and acceleration is 2. So you will get 130 Newton. This part is upward because it will accelerate upwards. Now, Add them together. F total is W plus F, and you get 767.65 Newton. So the next question is C. So just use the same formula F equal to ma, but acceleration that is 0, and you will get force equal to 0 Newton. So the total force is uh, 637.65 Newton. So the equation is use the same formula, and the mass is given in the question. So A is already given equation, that is negative 2, and you get negative 113 Newton. This is negative, so this force is downwards because it's negative. So the total of force is you have to minus it, and you get 507.65 Newton. Okay, we move on to the question E. So just use the same formula F equal to ma, which is mass is 65 kilogram and acceleration is 2. So we get 113 Newton. This force is negative y direction, so it also downwards. So you have to total the force W plus force, and you get 670.65 minus 113, and the final we will get 507.65 Newton. So the question F, same as C, you have to calculate the force, which is W plus 0, and you get W equal to 637.65 Newton. And the last question, which is G, just use the formula F equal to ma. Mass is 65, that's already given in the question, and A is already given is 2, and you get 130 Newton. This force is upward because it's negative downwards. This direction in y direction. So you have to calculate the total force, and the final answer you will get 767.65 Newton. Okay, we move on to the next part, that is discussion. An object can accelerate or change its state of motion as a result of force. It is measured in Newton and is commonly denoted by the symbol F. A push or a pull on an object may be compared to a force. Gravitational force, electromagnetic force, and contact force between objects are only a few examples of the various sources of the force. On the other side, mass describes how much matter is contained in an object. It is measured in kilogram, kg, and frequently represented by the symbol m. Since mass is a scalar quantity, the gravitational field has no effect on it. Simply said, an object mass is a representation of its inertia or resistance to change in motion. A measure of how quickly an object velocity changes is called acceleration. It is described as the rate at which velocity changes in relation to time. The vector quantity of acceleration is typically denoted by the letter A, meter per second squared m over s. Is unit. Acceleration can be zero when there is no change in velocity, negative when an item slows down, or positive when an object accelerates up. The relationship between force, mass, and acceleration is described by Newton's second law of motion, which states that the acceleration of an object is directly proportional to the net force acting on it, and is inversely proportional to its mass.
And next part is conclusion. In conclusion, the concept of force, mass, and acceleration are intertwined and form the foundation of Newton mechanics. Force, as an external influence, can cause change in object motion. Mass, on the other hand, represent the amount of matter in the object and determine its resistance to change in motion. Acceleration measure the rate of the change of the object's velocity, indicating how how quickly its motion is changing. Newton's second law of motion revealed the relationship between these three quantities. The acceleration of the object is directly proportional to the net force acting on it and inversely proportional to its mass. This law allows us to understand and predict how objects behave when subject to force. The study of the force, mass, and acceleration is essential in fields such as engineering, physics, and everyday life, helping us comprehend and manipulate the physical world around us. That's all.